Do you know the most expensive calculator in the Play Store? Well, this one costs around $270. The app has some basic functionality which we can easily create using Kotlin and Jetpack Compose. So without any fancy libraries, now without any further delay, let's go together and build the most cheap calculator in the world. Okay, now before we start here to build our calculator, you can just navigate inside here our UI and inside here our theme. I have changed the colors. I have added these colors here, and also when you navigate here inside our theme, I have changed here inside our light color palette. So you can just get the initial project inside the GitHub repository here, where you can just copy everything and you're just good to go. Okay, now let's navigate inside here our calculator, and we can just create here a new Kotlin class or file. And basically we're just going to select here file, and we can just call this calculator. Okay, so this is just going to be our calculation class, where we're just going to put everything what we are going to use to aid us in calculations. Okay, now let's assume we have this simple expression here where we want to solve. As human being, we can easily solve this by taking 3 multiplied by 2 here, where we're just going to get 6, and then we add this by 4, then we get the answer to be 10. However, for the computer here, it has to perform a lot of scans in order to get the answer. So the first scan here is just to perform this calculation here in order to get the answer 6, and then it's just going to add by 4 and get the answer to be 10. Now, this is not particularly efficient for the computer. Assume we have something complex like this, so we have to perform a lot of scans in order to get just a simple answer. So how can we solve this problem here? So there is a simpler way, which is just requires us to perform only one scan, and also is much more efficient for the resources. So let's see how we can just easily implement this. So to solve the problem, we have to convert the Infix expression to Postfix expression. So maybe wondering, what is the Infix expression, Postfix expression? Well, an Infix expression means we have operators in between of 2 operands or numbers. As you can see here, we have this simple expression 5 added by 3 multiplied by 2, and the operators are placed in between of 2 numbers. So the priority of operators is required to solve the expression, so the precedence and associativity. As you can see here, the precedence of multiplication is higher, so we have to perform the multiplication, and then after that we have to perform the addition. So we have to perform multiple scans to solve the equation, which is not efficient for computers as stated earlier. So how can we solve this? We have to use a postfix expressions, means we have the operators placed after operands or numbers. So we have to remove these operators here in between of 2 numbers and send them after the numbers, which is just going to be equivalent to this number here, 532 asterisks and addition here. So this is just going to be efficient, and the evaluation starts from left to right. So this only requires a single scan to evaluate, which is efficient to computers. Okay, so now in order to perform this inside our code, we have to perform using an algorithm. So we have here a simple algorithm. As you can see here, the algorithm states that we have to scan the symbols of the expression from left to right, and for each symbol we have to do the following. So if the symbol is just going to be an operand or a number, we have to add it inside the postfix expression result. And if a symbol is just going to be a left parenthesis, we have to push it inside a stack. So a stack here is just going to be, for example, an array list, which we can easily pop and move things outside. So we're just going to see this inside our code. And if the symbol is going to be a right parenthesis, we have to pop all the operators from the stack up to the first parenthesis and add on the postfix expression, where we are just going to create this inside our code. And if the symbol is just going to be an operator, and we have to check here 2 cases. If the precedence of the operator in the stack are greater than or equal to the current operator, then we have to pop the operator out of the stack and add them inside a postfix expression and push the current operator onto the stack. And else we have to push the current operator onto the stack. Now let's see the summary of this here inside our expression. Okay, so we have here our infix expression and postfix expression, and also here we have a stack. So the stack and postfix expression are currently empty. So let's use the algorithm to transform this infix to postfix. So the first thing, whenever we counter the right bracket, the left bracket, we have to push it inside our stack. And after that, then we are just going to get here another variable, which is just going to be a number. And for this case, whenever we get a number, we have to directly put it inside our postfix expression. And now we are just getting here an operator. Now we have to put it inside our stack first, And if we have to look first if there is no any operator inside here, and currently there is no any operator, now we directly put it inside our stack here. And also we encounter again the number, we have to put it inside our postfix expression. And now we are just getting an operator here and an operator here. So what we have to do is to check the precedence and the associativity. So the precedence here, they have the same precedence, and this must be performed first before performing the minus. So we have to put it inside our postfix expression. So we have to pop it outside here, and we have to push this inside here. So for that case, our plus has gone inside our postfix expression, and we have added the minus inside our stack. Now we have to check here, this is also a number, then we push it directly inside our postfix expression. Now we are just getting a right bracket. Whenever we get a right bracket, we have to pop everything which has been inside here, the stack, and we have to discard or delete these two brackets here. And for that case, we have deleted everything, and now our stack is empty. Also, we are just getting here another operator, and this operator, there is nothing here, so we are just going to put it directly inside here, our stack. And again, this number, we're just going to put it inside here, our postfix expression. Now we are encountering here a minus, and we have to check the precedence and associativity between these two operators, and the minus here has less precedence than this multiplication. So the multiplication must be performed first before we perform this minus. So we have to pop this outside the stack and put it inside here, our postfix expression, and we have to keep this inside our stack. Now again, we are just getting here another bracket, so we have to put it inside here, our stack, and then we are encountering another number, we are going to put it inside here, our postfix expression. And also, whenever we find here another operator, we have to put it inside here, our stack. Now we are getting another number, and again, we are just going to put it inside here, our postfix expression. Now, whenever we encounter a right bracket, we have to pop everything before this left bracket here, and we have to discard these two brackets here. And for that case, we are just remaining with a single operator inside here, a stack. And for that case, we have to remove everything so that we have an empty stack and an empty infix expression. So after that, we have here our postfix expression. So as you can see here, it's just really easy. Now let's implement this inside our code. Okay, now let's create here a class, and we are going to call this infix to postfix. Okay, so we are going to perform a lot of checks here, and we want to create helper functions that are going to help us to perform this conversion. Now for a case here, let's create a private function. And this is going to receive a character. So for that case, we can just call here char. And this one is going to return a boolean. Okay, now let's create here a when function. Now let's use this character. So we know that we want to check if this is not going to be numeric. So whenever we have these operators here, so we have the addition, the minus, multiplication, division, and all of other operators here. Now, when we encounter this, then we want to return true. And otherwise else we want to return false. Okay, now let's create another private function here, which is going to help us to get the precedence of the characters. So we can just call this operator precedence. And this is just going to return an int. So let's check here inside our when statement. And also here we're just going to pass in a character. Okay, so right now here we want to check if this is just going to be an addition or a subtraction. So we can just check this between these two things. Then we want to return this to be the lowest precedence. For our case, we're just going to return 1 here. And also let's check here the next precedence, and here we want to check the multiplication. We're just going to pass in an asterisk and a backward slash here, and for this we're just going to give it a precedence of 2. And also here we want to check other precedence, which is just going to be the power, and for that case we're just going to give it a precedence of 3. And if it's not inside this, then we have to return just a lowest precedence. We are going to return -1, which is just going to be not an operator for this case. Okay, now let's create a function that is going to help us to perform the conversion. So we can just create a little room first. Okay, now let's create here a function and we can just call this postfix. And this is just going to receive a string, and this is just going to be the infix expression, and also it's just going to return a string, which is just going to be our postfix expression. Okay, now let's create here an immutable variable, and this is just going to be the result, and this is just going to be our postfix expression. And for the first time, we're just going to assign it to be an empty string. Now we want to create a stack where we're just going to be inserting our data, so we can just call this st, and we can, inside Kotlin here, there is a way which we can easily use a stack. This is just called the array_deque, and this array_deque here, we can just pass in here a character. So the array_deque here is going to give us access on both ends, so the start and the end of the list. So we can just easily remove, add items, or get the first or the last item. So for our case, is just what we want to use inside here, our postfix conversion. Okay, so here we have our array_deque and our stack. So we want to create an extension function, which is just going to help us to do the conversion. So we can just come below this, and below here, we can just create a little room first. And here basically now we want to create a function, and this is just going to be an extension function, and we can just call the array_deque of type T here also, and we want to call this push. So this is just going to add the element, and here we can just call element, and this is just going to be of type T. And here what we want to do is to add the last item. So here we have the access to the last of the stack, and here we can just pass in the element. So this is just going to insert the data at the last item. And also here we want to pop, which is just going to remove and get the item. So we want to call this pop, and this is just not going to get anything. And here we want to call this remove last or null. So this is just going to remove the last item, and then it's going to return that last item which has been removed. And for that case also we want to create another, which is just going to look for that item without removing it. So we can just call this pick, and for our case here we can just call last or null. So it's just going to see the last item. So it's just going to look for the last item, or it's just going to return null if the deque is going to be empty. And for that case, we have our extension functions. Now we can just jump inside here our array and start to use it. Okay, now let's perform here our check. And the first thing here, we have to use a for loop for this case. Now we can just check for this inside our string, which is just going to be an infix expression. So we can just check this as inside this infix expression. Now let's create a little room here. Now what we want to do, the first thing we want to check if this is just going to be a numeric variable, then we want to append it inside our result. Now for that case, we can just check here if this is not going to be a numeric, and we have to pass in here our character, which is just going to be s. So if this is just the case, then we want to append this inside our result. Okay, now let's perform the next check, where we're just going to look for the opening bracket or the left bracket. So we can just call here else if. So we can check here if this first character here is going to be equal to the opening bracket. Then what we want to do here is just to push this inside our stack. So we're just going to push everything inside here to our stack. So because here the brackets has higher precedence, so anything inside here, we have to put it inside our stack. Okay, now if this is not the case here, we have to check the other case. So we can just check here if we encounter the closing bracket. Okay, so whenever we encounter here the right bracket, we want to insert, or we want to remove everything inside our stack until we find the opening bracket. And also we have to append those data inside our result. And we can just easily achieve this by using a while loop. So we can just create here a while. And the first thing here, we want to check that the stack is not going to be empty. And also here we want to check if the stack, so we want to look for an item without removing it. So here is just a good place where we can just use pick, which is just going to look for the last item here. And also we can just check this if this is not going to be the opening bracket here for our case. And if this is not the case, then we want to take the result. And here also we want to append an empty string, and for that case we want to get the data and also to remove it. So we can just use here pop, and here pop now gets the last item and also remove it inside our stack. And for that case also we want to discard the brackets, so we can just easily call st.pop when we finish here. Okay, now if this is just, we have finished everything, so we know that we are going to have an operator. So we have to create here an else block. Okay, so now here we have already finished to perform those other checks. Now here we have an operator, so we have to deal with operators. Okay, now we want to remove all of the element inside the stack whenever the operator precedence is of the infix operator is less than the operator precedence inside our stack element. So we can just do this by using a while loop first. And the first thing here we have to check if this stack is not empty. So if this is just going to be is not empty. And also here we want to check the operator precedence. So you can just call this operator precedence here. If this is just going to be less than or equal to the operator precedence inside our stack element. So you can just keep this inside the next line first. And here now we have to get the stack element, and we can just call here pick. Okay, so whenever the operator precedence is less than or equal to the operator precedence inside our pick element, and this is just going to be inside the last element inside our stack, and for that case we have to remove it and append it inside our result. So we can just call here result. Okay, now when we finish up this case here, so we know that outside here the operator precedence of the infix operator is just greater than the operator precedence inside our stack element. So outside here we have to put it inside our stack element. So we can just call this st.push. And here basically now we can just pass in this s. And also here we have to append a result separator. So we can just call this result, and here we can just append this. So we have a space separator which is going to help us inside when we are just doing calculations. Okay, so now I think we have finished to perform our check. So we have remained with data, for example, inside the stack. So we have to deal with it. So let's first corrupt this our for loop here and create a little room so that we can just deal with this. So the first thing here we want to also append a space separator. Okay, so here we can just perform here a while loop so that we can just remove everything. And first here we have to check if the st is not empty. So the stack is not empty. And if this is just the case, then also we have to check if there is inside the stack there is an opening bracket, then we have to return an error. So the user forgot to close the equation. So for this case here we can just check. So if this is just going to be equal to the opening bracket, then here we have to return error. And otherwise else, so everything is good. Now let's pop this inside our result. So you can just call here result. And also here we have to add the space separator. So I think everything here is good, and we have finished to perform everything and all of our check. Now we have to return. And we have to trim the trailing and the leading spaces. So we have to remove the space at the starting and ending of our line. And for that case, we have our result ready for use. Okay, now I think everything is good here. So let's try here our infix to postfix conversion. So we can just come inside here our main activity. So the first thing here we have to create a function that is going to give us a postfix expression. And for that case here now we can just calculate. So we can just create here another variable and we can just call this result. And what we can do here, we can just call our infix to postfix. and we want to pass in here our conversion, and we can just pass in here our infix, and we can just create here a log. Okay, now let's try to rerun and see here the output. Our app has launched successfully, and here we have filtered our log by using this postfix here, and here we have our postfix expression, and as you can see, we have successfully converted this infix expression and to this postfix expression. So guys, let's leave it here for this video. So in the next video, we're going to see how we can easily evaluate this postfix expression. So if you find value out of this video, please don't forget to provide a like, and also don't forget to subscribe to not miss new videos. Bye bye for now. Until next time.